Hello everyone, good morning. Hope you all can hear me out.
Yeah, hi, good morning.
Great. We'll start in a couple of minutes. People are yet joining, so we'll just wait for 2 more minutes and then we'll start. So let's start. So what we have covered over is we understood about what is big data, and we understood about Hadoop, how Hadoop can help in solving the problems of big data, and the HDFS workflow, the MapReduce principle behind it. And we have also seen how to create an account in Databricks Community Edition, right? So hope all of you are having your account generator inside the Databricks Edition. Anybody is yet to do with the account generation? Okay, great. So no worries on that part. So once you create an account, so this is how it will look like. I think again, this we have discussed over in the last session, which is once you create an account inside your community edition, this is how your page will look like, right? On your left side, you will have different options and there will be a cluster which will be up and running. Correct? So any questions till this place on what we have seen in the last session? Creating an account and logging in inside the Databricks Community Edition. Is there any question till there? You will see how Spark is efficient, how Spark takes over MapReduce and all those, right? So have we seen the in-memory computation part of Spark? I guess we haven't touched upon that. Can somebody confirm? Nipali, do you have any idea? We haven't started the in-memory computation, right?
Yeah, right. Not
Perfect.
yet it has started, I think.
Yes. Okay.
Hey, hi Sylvia. Can we get the link for this page to log in? Because I cannot
Uh,
see login option.
Login option, just go Google it out on Community Edition login. So you can just search Databricks Community Edition login. So the first link, whatever you are finding,
Okay,
the link
got it.
to get it. Okay. Fine. So now let's understand what is in-memory computation, because that's going to help us do the lab part also moving forward. So let me bring my board. See, I would like to revisit the MapReduce concept once, whatever we have learned, right? So the thing is, so it's basically a cluster where we have a master system and we have slave systems, right? So slave 1, slave 2, and slave 3. Imagine a file is there, gets divided into 3 blocks, say A, B, C. Block A is here, B is here, C is here, right? Now every slave system works individually on the particular block, generates the output, and how the MapReduce will finally reduce it. any one of the node which is having enough CPU cycles will go ahead and do the job of reducer, wherein, for example, let's say the slave node 3 is having enough CPU power. So your master is suggesting, okay, slave node 3, you go ahead and do the job of reducing. So what basically your slave node will do? It will try to read the intermediate output generated by all the other slave systems, which means it will be like OP1, OP2 and OP3. Together it sum it up and generate the final output. Okay, this is the overall map reduce process which we have discussed. Now let's see what is the biggest advantage here which makes people move towards Spark. Right? Now one of the first very big disadvantage of MR or map reduce is it cannot support real-time data. Meaning, if I have a data sitting under a particular location, the entire data, which could be of 100 MB or 1000 MB, whatever it is. If the entire data is sitting inside a particular location, yes, your Spark, your MapReduce can go ahead, read it and process. On the contrary, if you are getting streaming data, for example, data comes to you at a speed, let's say 50 Mbps or 100 Mbps or whatever, your MR cannot handle such real-time processing. That becomes one of the biggest challenge of your MapReduce. Second is, as per the architecture that we have seen here, it involves huge disk I/O. Now, what do you mean by huge disk I/O? Let's discuss that. See. Now, forget about the HDFS part for a while because we are only talking about the MapReduce, which is the computation section. Right? Now, in your map, what basically happens is, during the time of reducing, there will be blocks which gets read, the intermediate output that needs to be read from the different other system. So for example, if I take disk read, how many disk read will be involved during the time of map reduce? Which is basically during the time of reduce operation alone, I need to read the OP1 from here, S1. I need to read the OP2 from S2. So can I write 1 plus 1? One discrete from slave node 1, one discrete from slave node 2. Because their respective intermediate output is stored inside the hard disk of the respective node. Correct? So two discretes are involved. Of course, OP3 is inside S3 itself. It will be available on the cache. There is no need to perform any disk read over there because it is available on the cache itself, right? And coming to the disk write part. Now, how about the disk write part, right? Now, when it comes to the disk write part, initially these intermediate output has to be written after processing the block A on the slave node 1. We have to generate the OP1, right? The OP1 needs to be written inside the hard disk so that it can be read by S3 or whatever node which is doing the reduce operation. So here one disk write is there, which is writing OP1 inside S1. Similarly, writing OP2 inside S2, there is one more disk write, right? Similarly, writing OP3 inside S3's hard disk, again one more disk write is involved. 3 disk writes. Correct? And finally, after consolidating all of these output, I need to generate the final output, which also has to be written inside the hard disk. So one more disk write is also in. So if I sum it up, all the disk IOs together, how many basically we are having, including the read and the write, which is considered as disk IO? I will have overall 6. Right? Initially writing the intermediate output on the respective disk and then reading the intermediate on the respective disk and consolidating and finally generating one single output. Now, all of this put together, I will end up in having 6 disk IO operations. Now, the challenge is, please observe this carefully. For a file of 3 blocks, I end up in performing 6 disk IO. So I can roughly say for a file of n blocks, I can say I will end up in doing 2 n disk IOs. Now in your real world scenario, you will definitely end up in having 100, 200 odd blocks. So the challenge is it becomes twice the number of block size becomes your disk IO operations. Okay, what's the biggest challenge on that? As we know, any disk operation that we perform, it will incur a huge amount of time. The latency has been highly increased. Got it? So the biggest challenge in your MapReduce is it involves huge number of disk IO operations, which makes the overall processing really slow. This becomes one of the another huge disadvantage of MapReduce, which makes people move towards Spark. Got it? Please take a screenshot if you wish to. I'll erase this out and create another one for Spark.
Can you explain one more time the disk read?
Okay. The disk read, see basically how the read happens, only after the data is stored inside the disk, the read will happen. So previously these intermediate output has been written. After generating the output of block A, block B and block C, the respective output has been generated and they have been written. Now a particular node has to come and consolidate all this intermediate output, right? That is what the reduce phase do. What does the reduce phase do?
Yes.
Read all the intermediate output and generate the final output. So in order to do that, it has to first understand, okay, where do we have parts of this file? Okay, I have it in S1 and S2. So those guys will be having their intermediate output. And hence I have to read it first in order to do the job of consolidation. That's where 2 reads are involved because you have 2 other output apart from the output which is inside S3.
Yes.
Got it? Fine. So now, this being the huge disadvantage of your MapReduce, let's see how Spark is trying to overtake it. I'm going to clear this out, guys. I guess people who wish to take a screenshot has taken it already.
Yes.
Hey,
If I
Sylvia.
know S3 don't have any read, like this read.
No, because in the S3 itself, the consolidation happens. So the output which gets generated, which is available in the cache of that system itself. So there is no separate disk read will be involved there.
Okay, so it can be in any of the A, B, C, right? Yeah, just take an example of it. C here. Right?
I'm just trying to take an example where consolidation happen in S3. But if suppose S2 is having enough processing power, it will happen under the S2 node also. So that's why it is just 2. I'm not writing S1, S2. It could be any 2 systems. Whenever we have 3 systems, any 2 systems, disk read should happen.
Oh, okay.
Got it?
Yeah.
Fine.
Hey,
Now,
Sylvia, can you explain about the write one more time? How it comes to 4? Couldn't get
okay.
that one.
See, disk write, when you take it as 4, see how many blocks we have? We have 3 blocks.
Yeah,
So every block will have its own intermediate output. IO1,
correct.
IO2, IO3. So overall it sums up to 3.
Yeah,
The final output I have calculated, no? After consolidating all this intermediate output, I'm generating my final output on the reduce system. Right? Wherever reduce operation happens. So in our example that we have seen, I have mentioned it as S3, which is a slave node 3, where the reduction operation happens. Right? Now, after consolidating all of them and generating one single final output, that should also be written in the hard disk because that is the final output. I don't bother about these intermediate output once the final output gets captured. Correct? So when you sum this up together, we will end up in having 4 disk IOs. Clear now?
yeah.
See, also remember one thing, guys. See, whatever I'm talking about here is all imagining that it is in a positive scenario. Everything goes smooth as expected. Now also remember there is a possibility of a node can go down, right? Remember, recall the stuffs that we have learned on the previous week, wherein there is a possibility that one or two node can go down. Then in that case, an additional disk read or disk write will also be involved. So in a worst case scenario, it will even go higher. So in a minimum all positive scenario itself, if I have an n block, I end up in having two n disk IO operations, right, which itself is huge. But then if we include all the negative scenarios, okay, after slave node 1 generates the intermediate output, slave node 1 goes down. Then what I'll do? I'll go to the system where I found the replica of S1. Then I'll again redo the entire process. So overall, your disk operations will again become much more higher only, and it's not going to reduce at any point. Now this makes the entire approach of MapReduce really slow, and we need another framework which can help in minimizing these disk IO operations. See, in any cluster for that matter, the disk operations are a huge culprit because the overall efficiency of your cluster goes for a toss if there is too much of disk operations involved. Basically, the shuffling itself will make the process really slow. So what do we mean by shuffling is data transfer across a system. The more data transfer occurs, the more time it will take, efficiency goes down. And on top of that, disk IO operations will also slow down the perf. Okay, so let's see how Spark can overcome it, or what is a new approach Spark is offering to minimize these disk IO. Simple. Let's again get into master. 3 slave nodes. Okay. Again, I am having 3 blocks. One point here to be understood before I explain the frame. Now, Spark does not have a default file system. A very important point, something that is often been asked in interviews too. Now, what do you mean by it does not have a default file system? Now, tell me what is a default file system for Hadoop?
That's DFS.
Exactly. Right? And it has 2 major components. Now, any data that I want to process inside Hadoop, that's going to be stored inside HDFS. And processing approach will happen through the MR. So when we say I'm going to deploy a Hadoop cluster, it's like a full-fledged cluster. You have the storage also and you have the computation also. But the biggest challenge in Spark, now I wouldn't call it as only challenge. It can be considered as an advantage also in certain situation, which is it does not have a default file system on its own. Now, then the immediate question that comes is, okay, then from where Spark will read? Right? We all know it's a computation engine, but it needs to read from a file system, right? And it does not have one on its own. So how Spark is going to read? Spark is highly compatible with all the major file systems out there, which makes it highly integrable with all of these file systems, which can be taken as an advantage. See, because suppose imagine you're working for 3 clients. Okay, so the client 1 is saying they have their entire business data inside AWS. Client 2 is saying, no, I have the entire data inside GC. And client 3 is saying, no, I have the entire data available in Azure. And few other clients and few other distributed storages, right? Now, all these 3 clients, they are saying, no, I want to read the data in this respective file systems, and I want to process them through the Spark framework because that offers maximum efficiency. Now, the great and the good part is it can easily get integrated with all these 3 different file systems. The computation engine is one, but it can read from all these 3 different third-party file systems. Now, people can also consider that as a disadvantage because it has to depend always on a third-party file system because it's not having one on its own. It needs to be dependent on another file system. And compared to all the file systems out there, it has high compatibility with Hadoop. Now, numerous reasons for that. Both comes from the same software foundation. And Hadoop's MapReduce approach only makes people move towards Spark. That only, like ignites the decision or ignites the framework of Spark. So obviously, Spark is highly compatible with Hadoop, but that doesn't mean it cannot get integrated with the other distributed files. This integration is much more simple and easy, right? So in whatever platform you're going to have your Spark framework running, Spark can read the data from there, right? Now to understand this framework right now, I'm going to imagine Spark is reading it from HDFS. As you guys now have an idea on HDFS and its workflow, let's imagine Spark cluster is built on top of a Hadoop cluster. So it is reading it from the HDFS layer. Right. Now, in HDFS, how a file will be splittered, how a file will be stored, all of you know, right? Now, I'm having a file being divided into 3 blocks, A, B, C. There will be replicas, of course, right? I'm not writing them down, but yeah, there will be replicas. Based on the default number, there will be replicas also, right? Now let's see the processing approach, because storage layer, it is same as HDFS. There is nothing new that we need to learn. But let's talk about the computation, okay? Again, similar to MapReduce, a program comes, okay? Now the program is shared to all the 3 different nodes because we have 3 blocks. Program goes to all the 3 blocks. Now please observe this carefully. Now what happens? The program is again like same as MapReduce. The program is applied on top of this block and it generates an intermediate output. Just exactly same as MapReduce. But what is the biggest difference? In your MR or MapReduce, we will write these intermediate output on the respective hard disk of the node, right? Wherein here what Spark is suggesting, you bring the data, you bring the block A, whatever block that you are having to process. Bring the block A and store it in the RAM of the respective node. Okay. Now all of us know what is a RAM memory, what's the difference between hard disk and a RAM, which one is more efficient. Yes, right. I'm not getting into that side. So the block is basically moved into the RAM. From there, your processing happens and the intermediate output generates. And the intermediate output will also be written back into the RAM only and not on the hard disk. Now that's where the biggest catch is. Earlier approach of MapReduce, I will write them straight away into the hard disk of the respective node, wherein here, I'm going to store it inside the RAM of the respective node. Same happens in all the slave nodes. So imagine this is your RAM space. You generated the intermediate output, store it in the RAM. Similarly, here also, you generated OP3, store it in the RAM. Got it? So now all the intermediate outputs, the first point to note down, all IOs, intermediate output is what I'm writing as IO, okay, are stored on the respective nodes of that respective slave. Okay. Okay, so what is the benefit out of it? Right? Now, the reduce phase has to kick in, which is a consolidation phase, same as, because right now we have individually processed it. We haven't calculated the final output. Now here comes again another interesting approach of Spark, which is called distributed RAM. Distributed RAM or distributed memory. Now, what do you mean by that? Simple. Again, the master will pick up any one of the node to do the job of consolidation, just like in MapReduce. So maybe probably this time I'll imagine it to be S2. Okay. Now S2 is having higher processing power. So what master is saying, okay, now you go ahead and do the job of reduce. So in order to reduce, what are the things S2 need? What are the data S2 will need?
Huh?
Output from the other two systems.
Simple, right? OP1 and OP3 from the slave node. Now earlier what happens? We did a disk read from the respective nodes because the data is available inside the hard disk of those systems. But right now, they are available inside the RAM, and with the help of this new approach of distributed RAM, all these systems can share the data to the system which is performing the reduce through the RAM itself. Now, which will highly help me in decreasing the disk IO process. And my latency, that is my waiting time, will highly go down. I don't have to wait too much because there is absolutely no disk read and write being involved. Great. I perform the consolidation. I got the data from the RAM. I keep it inside the RAM of S2, generate the final output. Now, of course, this final output has to be stored inside the hard disk. Any idea why it needs to be stored in the hard disk, unlike in the RAM? Because all the intermediate outputs we are talking, okay, let's go ahead and store it on the RAM. But after consolidating the final output, we need to maintain inside the hard disk. Why so?
It is permanent.
Simple, right? Straightforward. Because you need the output to be permanent. All the data inside the RAM are temporary, that even if that particular node goes down or if the RAM space gets, if it gets neutralized, then that particular data will be erased out. It's basically a temporary memory. So for that reason, the final output, right, will be written back into the HD of the respective node. So in the overall process, right, the disk write itself is only one, which happens only at the end of the entire process.
Can you describe distributed RAM memory once again?
Yeah.
How
See,
it's shared?
See, distributed memory is just like a similar concept of a distributed file system. In a distributed file system, what happens? You're reading the data from the disk and sharing it across a system. In your distributed RAM, you are reading the data from the RAM and sharing it across a system. That's the only difference. That's why the name is also ideally same. Instead of disk, it's going to be the RAM. The data gets shared between the system through the respective RAM, not through the disk. Okay. So clear on how the disk write is being reduced here, or overall disk IO itself has been reduced here, right? So disk IOs have been minimized. Number two, which was again a huge disadvantage of MR, wherein Spark can handle real-time data as well, which means streaming data as well. And the great thing is, it can read it parallelly and it can process it parallelly also. So, for example, let's say 50 MB of data comes to you, 50 Mbps is a speed in which the data comes to you. It can read it, and while reading, it can parallelly process it. So there is a separate component for that, which is called Spark Streaming, which will basically do the job of real-time processing. So the two major disadvantages, see, of course, there are a lot of other disadvantages too, but then these two needs to be really addressed because that eats up a lot of our processing time. And Spark can highly handle these two issues comfortably.
I had a question. So can we consider like stock market exchanges to be one of the direct or indirect examples of usage of Spark or similar systems?
That's a streaming data process because those data, they are not batch. No, now every single hour or every single minute, these data keeps on changing. They are fluctuating, right?
Mm-hmm.
So that's a good example for handling real-time data through Spark. And of course, these data, they are not minimal, right? It will be generated in an enormous amount. And these data can be structured or an unstructured data also. Again, Spark can handle them efficiently, both the types. So they are a good example of handling real-time data through a Spark cluster.
Good, thanks.
Yeah, any other question, guys?
I have one.
Mm-hmm.
So actually, I raised this point in the last class as well.
Mm.
But this topic was uh, not discussed. So basically, if we are consuming the RAM,
Mm-hmm.
it's been consumed from each of the node, right?
Mm-hmm.
So I'm slightly confused between the first and the second point. All inputs are stored in the RAM of respective node, and the secondly is the distributed RAM. So
Mm.
is it the same RAM shared across the different nodes, or uh, each nodes are having different RAM, but they are connected through a distributed system?
No, no, no. The first and the second are talking about the same RAM only. In the
Okay,
first point, whatever intermediate output you are, see, because what is going to be shared across these RAM? The intermediate output is what going to be shared. So obviously it has to be read from that same RAM. And there is nothing like a different RAM for storing a data, a different, see, inside your RAM, there will be splits. But then a
okay,
system, if you talk about, there is only one single RAM. There will be separate memory area for storage as well as processing. So when
okay,
it comes to storage, that is where persistence of data comes in. We haven't seen that. You will understand slowly. But then whatever we are talking about right now is just one single storage space, one single RAM space.
okay. And secondly, the major point is like, uh, I mean, generally the RAM has a shorter
Mm,
storage than the hard disk.
mm, mm.
So at some point of time, it will
Mm.
also be an issue for the Spark, right?
Exactly. That's a very, very valid point, and it's a very generic question that comes to all of you, because obviously when we say RAM, the two main important points comes to our head. One is it's a temporary memory, and one it is a shorter memory compared to the hard disk. Whatever system that you are having, if you can check, your hard disk will definitely be multi-folds of the memory of your RAM, right? So the question is very normal because I'm saying I'm going to dump the data into the RAM. From there, I'm processing. I'm going to store the data back in the RAM, the intermediate output. Now, as he rightly said, over a point of time, I will exhaust the RAM, right? And I'll not have any more space available in the RAM for the upcoming data. But I mean, obviously, this is one of the simple reason why people generally don't store anything in the RAM for a longer duration. But then Spark proves its efficiency here by a lot of algorithms inside it. So there is an approach called lazy evaluation. We will learn it once we start writing the code. We will learn it probably today, right? So during using this approach, as well as there is one more called DAG, wherein processing becomes really simple. Now, with these techniques in hand, and of course, persistent also in place, with these techniques in hand, I'm going to make the best way of handling the RAM space. Now there are by default some compression algorithms also comes along with Spark. So any data that you're going to take it into the RAM, it's going to be compressed by default. On top of this, these algorithms and approaches are also going to help us to efficiently handle it. But that's a valid point. We will see how we are going to handle it.
I had one more question too.
Mm-hmm.
We discussed that the RAM is also compartmentalized into storage and processing, right? So here, like, let's say if we run a comparatively bigger file or something to process it, so there will be like, of course, there will be three probabilities, but we'll be discussing the through that. One is like, let's say the storage becomes, out of, I mean, it gets overfilled, and the other is that processing becomes, overfilled. Then what do we see outside? I mean, what is the output? What is the difference in output do we see here when the storage is overfilled and the other is that the processing is, kind of over, yeah, burdened?
So that is basically called OOM, or also known as out of memory.
All right.
What do you mean by out of memory? So maybe probably if some of you are already working on big data domain or any other platform, wherein when you run a huge load and you process a huge file on your cluster, we might get a warning saying we are reaching out of memory, or sometimes we might get an error out of memory and hence I cannot proceed further. Now the challenge over here is when I will reach an out of memory, now before I consume around 80 to 85% of my entire processing power, I will be getting this warning saying like you're almost touched the threshold. So try to adopt some technique wherein you are minimizing the storage required or minimizing the processing power. Now that is where we will go ahead and optimize our, right? Now adopt new techniques while performing joining, or adopt some techniques to compress the data which is present inside a file. But then whenever these two reaches a threshold or about to reaches a threshold, this error will kick out. Now this is one of the, what say, like a demon error of your Spark. Now every Spark developer somewhere down the line in their career, they will face this issue of OOM, out of memory. Now that is where we will pitch in. We can either scale your cluster, which is increasing the system's power, or adopting more systems inside your cluster. So that's again a huge area, which is like scaling. We have vertical scaling, we have horizontal scaling. Now, a lot of such techniques are there. So we have something called salting. Now, all these techniques can be adopted to avoid this OOM. So certainly these issues can come, but we need to adopt some techniques to control it.
So what if suddenly the RAM is
Can we just confirm it from that person whether it's clear before we move on to the next one?
Yeah, I just had one more doubt. Like, this is perfectly rigid, right? The storage and the processing part, I mean, the composition of it, or is it like flexible?
No, it is highly scalable.
Or is it? Okay.
Yeah,
Okay.
yeah. See, if it is rigid, it's going to be really challenge for you. See, today you might be working with just 2 or 3 clients, and you have around, let's say, 10 nodes inside your cluster. Now, that's not going to be the way all out, right? You will grow up, you will end up in having more number of clients, or with that same client itself, you will end up in processing too much amount of data. So I need to be open up for scaling. Now, what I mean by scaling, I can go ahead and either increase the storage or the processing side of every single node inside my cluster, which is called vertical scaling. There is one more approach which is called horizontal scaling, which means adopting more number of slave nodes inside the cluster. You are able to visualize the vertical and horizontal difference.
Okay. So, this is like this can be this is manually done, or like the system recognizes it's on its own?
No. It needs to be manually added. You need to adopt nodes, right? You need to hire systems from cloud and you need to attach them inside your cluster. Or if it is going to be, see, vertical scaling is very rare because that involves the complete shutdown of that machine. Then only you can increase the processing power of that system. Horizontal scaling is a much better option, but of course the budget will go high.
Got it. Thanks.
Yeah, anything else, guys?
Yes, I just wanted clarity on the read and write. When you are talking about the Hadoop HDF processing, you said that the writing and the reading is done in the disk, and where you have RAM, read access memory, which I presume the writing and the reading will also be done there. So my question is, are we having 3 RAMs? Let's say we have 3 slave nodes. So we're having 3 RAMs, right? And then we now have another RAM for the final OP.
No, inside any of these 3 RAM only, your final output will also be calculated.
So
You don't
we're
have
only
a
having
separate RAM space just for the job of reducing. See, it is exactly the same as your MR process, just that instead of things happening by reading it from the hard disk, here we are going to do it from the respective node's RAM. Every node or every slave will have its own hard disk, which is your storage, and its own memory, which is nothing but your RAM. This RAM is what we are talking about whenever we are processing or whenever we
so
are writing.
so for in summary, like when we have like 3 blocks or slave nodes, so we are having 3 RAMs and 1 disk for the final writing or permanent storage.
Correct. Correct.
Okay. Oh, thank
Yeah, so take a screenshot, guys, if you wish to. I will be erasing it now.
One last thing. So
Mm-hmm.
in the MR phase, so MapReduce case basically,
Mm-hmm.
all these intermediate outputs, are they, I mean, are they purged after some time, or does someone has to manually delete the files?
A very good observation again, Pranjal. So certainly it needs to be deleted because see, think logically, when we generate the final output, we don't need these intermediate outputs because that's going to unnecessarily sit in the RAM itself. Of course, even in MR also, it will be unnecessarily sitting in the hard disk. So the approach of either MapReduce or Spark, both what will do, it will purge all these intermediate output right after the generation of the final output.
Okay.
Because once the final output gets generated, absolutely there is no need for these intermediate outputs. And if they are sitting in the RAM, they will ideally eat up a lot of your RAM space. Right? So the framework as such itself will take care of it. No manual effort needed.
Okay.
I have a doubt here.
Mm-hmm.
Since we are copying it to RAM,
Mm-hmm.
what if some disaster happens, like in
Mm-hmm.
data center, when you are doing some kind of
Mm-hmm.
a major output, in case if it goes, because once the power goes off,
Mm-hmm.
the RAM will remove all the data, right? With just a temporary one. Right? How will you recover at that point of time?
Yeah, perfect. Again, a very good observation. So I'll keep this question to all of you. So what do you guys think will happen? So her question is, okay, I have processed the data and I'm storing them in the RAM, right? So for example, this is slave node 1. I'm storing the intermediate output here inside the RAM of this node. Now what she is saying is, what will happen if this node goes down? Either during the time of processing the block or even after processing the block, in both scenario, right? Not necessarily only after generating. During the time of generation, let's say 30% of processing is completed, node goes down. Or you finish the entire processing, output is written into the RAM, node goes down. What do you think will happen? How we can recover from that? Think?
As it will not send the acknowledgement to the master, so master will have the data. So it will try to assign to some other node when you like
So
after some
does master have the data?
um
Remember, we even did one quiz also. No, master will not hold any data inside it. But your approach, your answer was right, but then it was not from the master. Remember, we are talking about HDFS as a workflow. What is a fault tolerance technique in HDFS? What's the fault tolerance technique here in HDFS? Exactly. Copy or backup is stored in some other slave node. As Soumya and Insha has rightly mentioned, this
yeah.
block A, which was a part of your file, will certainly be available inside any another node as a part of a replication factor. Now, the moment the signal gets lost, obviously the slave node 2, wherever we have a copy, that will bring the data into the RAM of the respective node and processing happens. Right?
And this
Perfect.
and this will be stored in the other node hard disk or RAM. It will be in that
It
RAM
will
only.
be in their hard disk. No, see, we are only talking about reading something from the file system. Reading anything from the file system involves disk,
Yes.
right? It will be in the disk, but we need to shift it to the RAM and start the processing in that particular,
Uh,
right? Clear on your question? Who asked that? Yeah.
Yeah, I got it. Yeah.
Okay. Yeah. Great. So now let's get in and start building some codes so that we can understand. Yeah, tell me.
If you are reading that from the backup node,
Hmm.
for the file system, then the same thing, like you are doing this here, disk read also, right? Like, but only in case of failure, right? Or
Exactly.
yeah,
Yeah,
okay,
because the failure is not going to happen during every read. But if in case a failure happens, of course I cannot handle this extra read because that is the only way I can read it.
okay, fine.
Right? Yeah. So now what we are going to discuss or how we are going to see the lab part here is, see, the overall framework of Spark can be categorized into 4 major areas. Like how in Hadoop you have 2 components, but that is over a component, individual component. But here in Spark, in 4 different approaches or in 4 different ways, we can handle the data. One is called core, which is the bottommost layer of your Spark. So whenever I download Spark from the official website, which we have seen in the last session. So if you go there, download the binary file of Spark, have it inside your system. And if you zoom in into the hard disk, and if you try to understand how it gets installed on the system, there will be a bottommost layer which is called Spark core. Now this can handle structured data, unstructured data, and even semi-structured. And the data abstraction, like how I'm going to handle the data, how I'm going to understand or read the data or process the data, that will be under the terminology called RDD. Right? But core is having some of the disadvantages which we will discuss. So which makes people move towards another component called Spark SQL. Now here, highly we will only work on structured data. But the biggest advantage of Spark SQL is it supports different file formats. It supports CSV, quite basic, JSON file format, embedded JSON file format. Have you guys seen or used JSON files on your course so far?
Yes.
MongoDB.
MongoDB, yes, exactly. So if in case you guys have learned the MongoDB module, there you would have touched upon JSON files. Now, what I mean by embedded JSON file is like the key value pair further gets broken down into dictionaries or lists or arrays, right? Embedded JSON and simple text file it supports. Avro file formats it supports. Parquet file formats it supports. It can also read the data from some other RDBMS and process. So the biggest advantage of Spark SQL, or why even if you could see, uh, there are too many requirements nowadays in Spark, and specifically asking for efficiency in Spark SQL or data frame handling in Spark, right? Because of the reason it supports quite a huge subset of file format, and among that, these Avro and Parquet are there, no? They are very commonly used file formats, and even ORC, I missed ORC. Don't worry if you haven't heard about any of these file formats. If you're seeing it for the first time, it's fine. We will be using them in our sessions. But to start with, these file formats are used a lot on big data platforms. And hence, Spark SQL is of highly and efficient component under Spark, which can handle all these files. Third one would be Spark streaming. Like as I have said earlier, it's for purely handling real-time data. And we have a GraphX component, which is again purely designed for processing unstructured data. To an extent, structured data is also being processed. But for your course on this module, we will be touching upon only in the core and the SQL part of your Spark. Okay. Now, to start with Spark core, you need to first understand its data abstraction, which is called RDD. Right? Have you guys heard about this earlier? Anybody?
Resilient data distribution, something.
Exactly. Yeah, exactly. It is called resilient distributed data. Now, I'm not going to spend a lot of time on RDD. Basically, I'm not going to spend a lot of time on Spark core because, as I said, the usage of that in the industry has been highly reduced nowadays because of its incapability in some of the file formats. So we will touch upon RDD to an extent, but then we'll go deeply and understand about Spark SQL related operations, because that is where even if you approach for an interview or even if you are planning to switch into big data, working with Spark SQL becomes really critical. Right? Fine. Now, yeah, I will start with this RDD. Okay. Little bit theory and then we'll get into the lab part. Now, what is this resilient distributed data? Simple. Imagine you have a file here. Okay. Now I'm talking about a Spark cluster. So going forward, we will be having a cluster approach, but that's not going to be referred as Hadoop cluster. We will be calling them as a Spark cluster. Now, few of the terminologies remain same. This is master, this is slave. No difference on that. The same heartbeat signal, again, no difference on that. Depending upon the file system from where Spark is going to read, the replication factors differ, right? Now, as I have mentioned earlier, we are going to talk about Spark plus Hadoop. So I'm going to read it from HDFS. So I have a file, right? Just imagine this file is having some huge bunch of numbers, right? It's an unstructured file. Having some bunch of numbers, no order on it. The file has been stored inside your HDFS, right? So the moment I'm saying the file is stored inside HDFS, you should recall all those concepts: replication factor, block size, default block, how many number of blocks, all these concepts, please try to recall, okay? So I'm imagining here to be 3 blocks, right? So this, what is this color? This beige color box that you could see over here, imagine that is the hard disk of the respective node. So the data is being splitted, data is stored in the node. There is also replication factor, but I'm not talking about it right now because it is an implicit understanding that every block will have the replicated copies too. Got it? Great. Fine. Now what's going to happen, right? Now, in your Spark cluster, the master service will have a daemon inside it, which will have a background process. Can you guys recall what are all the master service when we talk about Hadoop? Can you try to recall? Only the master services.
Name node.
Okay. And?
Data node.
Data node will not be a master service, no?
Yeah, that's a slave one.
Name node is with respect to storage, which is your HDFS. What is a master node for your MR?
The resource manager.
Resource manager.
Perfect. Perfect. Right? Now, similar to that, when I come to a Spark cluster, there is a driver code. So the naming convention is slightly differed here, but ideally it will do the entire job of the master process only. But how we call this as driver? Under the Spark terminology, we'll call this as driver because it drives the entire process. And the driver is in short called SC or Spark context. So when I say I'm going to run a Spark cluster, it means I have started my Spark context object. What is the usage of the Spark context object? Simple. Whatever your name node is doing. So what are the services a name node has to do? It will basically be written in a bunch of Java codes and it is uploaded on that system so that it acts as a name node service. Same here. Whatever the Spark related operations that needs to be taken care by your master will be compiled and will be kept as a code called Spark context. But here, the code will be in the language called Scala. Have you guys heard about Scala? It's a programming language actually. Right? Like how we have Hadoop entirely built on Java. Spark is entirely being built on Scala. It's again an object-oriented programming language, which has its roots from Java only. But then this is a core language on which the entire framework has been built. Great. Now imagine you have written a code in Spark and you're starting your Spark cluster. Okay. How the code will look like, don't worry about it right now. We will see it. Now the code comes. Okay. I'm writing a Python code. You can call your Spark through Python also, not necessarily always Scala. It has different plugins. So Python also can be used in Spark. Now the code comes to the master. Again, same logic. The master sends the code to all the slave nodes. Great. Right? Similar logic, nothing new. But here comes a difference. The moment the code comes, your slave node will basically move the block which I need to process into this black box. This black box is nothing but the RAM space within every individual node. Right? Now the code is applied. Whatever Python code I want to apply, that gets applied on the block and it generates an output. Right? That's basically an intermediate output. Now I'm naming these intermediate output as B4, B5, B6 and so on. Right? Then again, finally, the reducer comes in, which could be any of these three nodes. Read it through the distributed RAM, process it. We have seen it, okay? That entire process. What you need to understand here specifically is this block that I'm pushing towards the RAM, right? Now that block, no more I will call them as block. Rather, I will call them as RDD. So any piece of data that you are shifting into the RAM of your system and you're generating an output inside the RAM. So B1 is also an RDD. B4, which is the intermediate output, is also another RDD. Similarly, here B2 is an RDD, B5 is an RDD, B3 is an RDD, and B6 is an RDD. Now, why they carry the name resilient? Because of the replication factor. We are handling the fault tolerance. Like as we have discussed just now, something goes wrong to this system. The intermediate output gets deleted. No worries, you have block B1 available on another node. Pick it up from there, process it. Now that's why the data has been named as resilient distributor data.
It's just a new terminology. Everything else is the same.
Exactly. Because I cannot keep on taking up the same name in different frameworks, right? So that's the process. They have different naming convention here, but then the job is going to be exactly the same. Fine. Now this part we have seen. Now this
Excuse me, may I know
entire
what is this
Spark,
LDFS?
yeah,
It
tell
is a
me.
database.
No, can you repeat?
What is LDFS? It's a database.
What is you mean HDFS?
No.
HDFS is Hadoop distributed file system, no?
Okay. And that is external to Spark.
That's a file system from where Spark can read it. HDFS is basically the file storage of your Hadoop. So if your Spark is reading from Hadoop, it will read from HDFS.
Okay.
Okay. Yeah. Now, have you guys heard about PySpark? One very important doubt many beginners do struggle is what's the difference between PySpark and Spark? I was taking another session over the week and surprisingly, most of the beginners have the same question. So I don't know what is the difference between PySpark and Spark. So any idea on what's the difference?
I think it's a library to interact with Spark using Python.
Simple, straightforward, right? Now, maybe in the earlier phases, these these new terms might be confusing, but then please understand it. It's very simple. See, when the Spark framework comes in, it comes with a multi-language support, meaning if you are a Java developer, yes, you're most welcome to work with Spark. If you are an R developer, yes, you can still. If you are an SQL, like an SQL expert, yes, feel free to work inside Spark. If you are a Python developer, yes. And even if you are a Scala developer. So the simple thing is, the Spark framework can be accessed or you can process the data inside Spark through any of these language. And the greatest and the coolest part is, see, generally when we are deploying a framework, we need to make sure of the language installation. We need to integrate and all those. But the good part in Spark is, when Spark gets installed on your system, it comes with the language support for all this file. Now, you don't have to have an additional headache of downloading Scala or integrating them at the bash file. Absolutely not needed. Right? So when you are deploying Spark or when you are accessing Spark and processing data in Spark with the help of Python, then there is a library that I need to call it. Now that library, or probably I can call, imagine this is an interface between these two. That is basically nothing but PySpark. And this also comes by default when you download and have Spark in it. And inside this, there is a bunch of libraries called PY4J. Py4J. Now, I cannot show you that because we're going to work on Databricks. It's in the internals of Databricks. But by default, Py4J is there inside your PySpark. And with the help of that, I can write Python-related codes which work through the Spark. Simple. Don't get confused within these two terms. Okay.
Can you please repeat about the Py4J?
Py4J is just like, see, for example, you have NumPy, you have Pandas. What are these?
Yes,
They're
libraries.
basically some libraries. So similar to that, Py4J or Py4J is a package which contains a lot of libraries inside it. Now, that
Functions.
is the most needed library for working within PySpark.
Okay.
That's it. It's just like another library. Okay. Fine. Now, let's first understand how we can read some files inside Databricks. Tell me, have we seen how to access DBFS in your last session?
No.
You haven't? Okay. Fine. So, but all of you have reached this particular page, right? No worries on this.
Yes.
Okay. Now,
I'm unable to connect to the
no, don't worry on the connecting part. I'll tell you how you can connect. Okay. If you have reached this page, that's more than enough as of now. I'll tell you the steps one by one. Now, you know about the workspace. Workspace is a place where all your saved entries will be there. Great. Reasons we know. Okay. Search is fine. Catalog. Now, what is a catalog? Now, there are two options. One is a DB table and another one is your DBFS. What is DBFS? DBFS is nothing but data bricks file system. Now, how we have HDFS, which is Hadoop distributed file system. When I'm trying to read something from Databricks, it's going to be referred as DBFS or Databricks file system. Got it? And since I'm going to process my entire data through Spark in Databricks, I will be reading them from the DBFS file system itself. Now, how I can upload some content inside it? You can go and click on upload and do. But right now, I guess none of you are able to view this DBFS on your screen. Am I right? You are able to see the database table, but are you able to see this DBFS here in your screen?
Yes.
Yes, no?
Yeah, I can see.
Yes.
There is the option. Can't see any file.
Okay, so then I think I have explained about this. Otherwise, you will not be able to find because by default, this is not visible. Okay, I'll repeat the process. If in case you're able to see this DBFS, great. You don't have to do anything. But you are unable to see the DBFS. On the top, okay, go to your profile, click on settings. Okay, come to the advanced option. Scroll down, come to the other section. There is a DBFS file browser. Enable it out, toggle it on. If you haven't, that's where, oh, okay. Great, Insha. That's what I asked where we covered it or not. Okay, then I believe this is something that we have covered. Okay, if you toggle it on, then you are able to view the DBFS. And uploading part, click on upload, pick up a file from your drive and upload it. Great. Now let's start with the basic code. If you are able to connect to a cluster already, great. But if you are not able to connect, just follow me. Go to new, click on notebook. Okay. Or probably, yeah, this one. Okay. Now I'm just trying to run a simple code. If you haven't connected to the cluster or you are launching it for the very first time, just simply type a statement, click on this play icon. It opens up a new window, okay, wherein it asks create new resource, right? Click on that. Okay. It will say, okay, I'm going to create a resource to you under the name, say, my cluster. You can go by this default name itself. And this is a configuration. Click on create, attach, and run. Simply click on that. So now when you click on that, it will take few seconds and it will try to connect to your cluster.
Can you repeat the create? I was not able to see the screen. Or you can just tell me. Yeah.
See, just write some statement inside this, okay, and click on display. So for me right now, it is already started, so I cannot just replicate the same thing. What you have to do is click on display. You will get a new window, okay, and in the bottom, there is an option called create new resource in that popped up window. Click on that and then click on create, attach, and run. Okay, just do that steps. It will take few seconds, guys. In the initial time, it will take few seconds. Don't worry if it is taking a longer time for you. It will take. Now let's discuss on what this will offer, what this cluster will
I
offer.
have question. So in our last class, we created a cluster, but it's not available here under catalog. I can see it said I can't connect to cluster.
Yeah.
So how do I connect to the old one?
You don't have to connect to that same one because this is a community edition. It cannot come up with your. So for example, if you go into your compute, you might have multiple things, but then at least at one particular point of time, only one cluster will always be up and running, right? And in a community edition, directly coming into the compute and starting this cluster this option is not available. Even if you tried, it will say in this edition, you cannot start it directly from here. So this is not the way to start it in a community edition. In an enterprise edition, you can directly come here and start your cluster. But through a community edition, see, I'll show you. This is one of my earlier cluster. Okay. I'm clicking on the plus, which is saying, are you sure you want to start? But can you see this error? I feel.
Yes, I can see.
Right? Because through the community edition, it is not possible. See, it's not like you cannot start this way. For a free edition, you cannot directly start a compute from the compute section. That is where what we are doing is, I'm heading into the workspace, running it here, and then starting my cluster.
Hey, I'm
So
sorry,
for
but I'm getting lost here. I have just typed print statement, and after that, I should click on connect.
No, you should not click on connect. You should click on display icon, run cell.
Okay, yeah, after that,
Create new resource.
just a second. It's asking me attached to an existing compute resource.
You can either attach to an existing one or you can create a new one. If you have
Okay.
created under a name, it is available, then you can simply attach to it. But then the challenge is sometimes that existing cluster name, it will not give you. If in case it has been accessed somewhere else or if it is currently
Okay.
not available. So it is better to create a new one in those scenarios.
Okay, and after clicking on create, I have to wait, right?
Yeah.
Okay.
So
Okay.
here you will be finding some loading symbol happening.
Yes.
Fine. So now I'm connected to my cluster, right? I could find my cluster is up and running. How I can get to know? I could see this green icon, green dot coming up, which will tell me that it is running. Okay. So now if I run it, that simple statement gets executed. Great. Now let's start writing some code.
Please, I'm kind of lost in one. I'm trying to create a new cluster, the cluster name. So what I have is run all and connect, just like you have my cluster here. So under the drop down, when I click the drop down, I have create new resources.
Do one thing, wait. I'll give you access, just share your screen. I'll tell you what you need to do.
Okay.
I'll give you host access because I cannot give you separately the screen share access. Once you have done, you have to give me back the access. Okay? Yeah, go ahead. Anybody else who is also facing issue just like her, please observe this.
Can you see my screen now?
Yeah. Just go and click on that play icon. Okay. So now in her case, what is actually happening? Here is the bunch of available resources which she has already created it. Those will come on this drop down option. Now what it is asking is, since it is not available, can you see an icon here, something like this? Right? Now, which is basically like a cluster which is currently not available. Now, since this is not available, I cannot directly attach it because the attach icon has also been disabled. Can you see that, Ife?
Yes.
So in that situation, what you have to do, you have to go and click on create new resource. See at the bottom? Click on that. Yeah. Now, if you want, you can change the name of a cluster to something else. I would suggest go ahead with the same, but choice is yours, right? Type something. See, this is not an issue, Mahesh. This is how it basically works. So if at all that existing resource is not available, you have to create a new resource. That's it. Okay? Don't think this as an issue. This is the actual process. Now
Okay.
click on create, attach and run. Now can you see it's getting started?
Okay.
Okay. So going forward also, whenever you are playing it, if it is already available, the attach will automatically be enabled. But if the attach is not enabled, the attach button is not enabled, then it means you have to create a fresh resource.
Okay.
Is that clear, everybody?
Yeah. Thank you.
Yeah, can stop sharing.
Why are we attaching a resource here?
Then how we will compute? If we don't have a resource, we can't run any code on top of it. Right? We need a resource to run the code. We need your RAM, we need the processing part to compute our code, right? Compute is basically the processing part that we are asking. Okay. Now, let's start writing some code. Guys, please stay on mute. Yeah. Fine. So now let's start with some basic Spark core related operations. Now we know the data abstraction here is going to be RDD, right? Resilient distributed data. Now in your Spark codes, it is all about API. Have you guys heard about APIs? What is an API?
Application Program Interface.
Yeah, it stands for that, but what does it do?
It's for communicating between
It allows
servers.
communication between a client and a server.
Simple, right? Now, if there are two different services, I just want to establish a communication between both of them. Then we have an API call between them. So there is a service here, there is a service here. Now this service is sending a request, which your API can handle. It can send it back and then it collects a response back and it shares it back to the service again. So it basically acts as an intermediate service. Now in your Spark, all the operations that we are going to perform are basically called as or basically available through API, right? And these APIs are basically divided into two types. One is called transformation-based API and another one is called action-based API. Okay. Now, what is a transformation-based API? Simple. I have a data. I'm converting the data into some other form. For example, I'm going to give you a CSV file which consists of last 2 months of sales information of my business. Okay. Now, what I want you guys to do, take the last 2 months sales, come up with few calculations like aggregate sales of one particular product or aggregate sales happened in one single location, one single city, or for a particular product, what is a maximum sales or the minimum sales. So what you're basically doing, you're taking a data, converting it into different form by applying some operations. So if we want to do those, that can be handled with a transformation API, any kind of transformation basically, or aggregations. What do you mean by an action command? Action is basically to view the transformed output or to save the transformed output. Okay, so you transformed that last 2 months of sales into some other data you have generated, like let's say an aggregated data. Now I want to view those aggregated data, or I want to save it so that I can generate a dashboard or something out of it. Got it? That's where Action API comes in place. So any API I'm randomly going to write that will either fall in a transformation bunch or in an action. Okay. So now let's start with our very first API. Which is going to be text file. See, before I even start to transform, I need to load the file. I need to have the data with me, then only I can transform it. Right? Now, for that, I'm going to pick up one file right now. I'll share this file to you guys on your respective drive. Okay. So what I'm going to do, I'm going to pick up a file called social media comments here. Okay, I have uploaded the file already. It is available under my DBFS. Now I need to know the path of this file. Simply click this drop down option. You can find something called copy path. Click on that. And in that, it will be displaying you two different formats. One is a Sparks API format and another one is a file API format. Now we need the Spark API format. So click on the copy. Okay, close this, close this. So now I'm going to write sc.text file straight away. I don't need to call any PySpark related libraries, because please remember, Databricks is created specifically for handling Spark related operations. So all the Spark related libraries are already placed. They are up and running. The moment your cluster is up and running, all your Spark libraries are imported and they are already been available. So I don't have any need to separately call them out. Right? Unlike in Python, wherein I will be calling numpys or scipy in order to use it. Here there is absolutely no need because the default Spark configuration is already up and running. Got it? So now I'm going to load this file. This is a very first API that you are learning, which is for loading the file into an RDD.
Here, what SC stand for?
What does SC stand for?
Spark context.
That's it. Right? Because your Spark context is already up and running. The moment your cluster is up and running, it means you have triggered the Spark cluster, and Spark cluster cannot be up and running without the driver process, which is your Spark context. Now I'm going to store this entire loader data into an RDD. You can keep any name for that, just like you keep a variable name. RDD 1, 2, 3, whatever names you wish. Okay, so when you run this, what basically happens, the data which is available inside your DBFS is copied and it is getting loaded into this RDD1. Okay, now I'm going to run this. Just simply run it. It gets executed. Now let's do an action command. Action command or action API, which is going to be collect, take, or first. Now let's see these three action APIs.
Please, can you share the drive for the file? The drive
Drive
link.
is still not uploaded, but I can share you the file here in the chat if you want.
Okay, thank you.
Mm. Yeah. Oh, sorry, I shared it just to her. Yeah. I would recommend, I mean, see, right now I'm just writing one single line of code. Probably you can replicate it along with me, but then going forward, when we go little deeper topics, I would recommend don't try to do it parallelly along with me, because in the urge of doing it right, you might miss some of the important things that I say. So understand it and then you can do it. That would be the best way. Fine. So now I'm going to call the very first action command, which is collect. Okay. Now what is this collect command is going to do? Please observe this. Can you see what happens when I call that? So it's a little bigger file. So it tries to print the entire content here on the output. Now what does a collect API basically do? It is an action API. You have to remember these APIs. It helps to display the entire content of the article. Simple. Now, most of the time, we are not recommended to use a collect function, because whenever the size of the file is really huge, it becomes certainly a challenge, right? Because your cache gets occupied with a huge amount of data. So to avoid that, see, and at the same time, you're interested in viewing some sample data present inside the file. I don't have a need to see the entire content, but probably I'm looking forward to view some sample records, right? Then you can do take of n. N can be any number. But write 10. Okay, so just see this part. RDD1 dot some random number. So what it will do, it will try to display only the top 10 rows. So in a huge file wherein you're looking forward to just see only a sample, you can go ahead and call the take function. And take function is highly recommended and preferred over collect function. And similarly, you have the first also, which will only display the very first line of your article. Just the first line. Is it clear, all these three? So these three falls under action command. This is one of our very first API. We have to do much more, but this is a very first transformation. So as of now, things are clear?
Yeah, but these terms are, these are misnomers actually.
Sorry, these are?
Misnomers, they mean something else. They sound something else, they mean something else.
I don't think so. Collect it is basically trying to collect the output. Take is just like a top function or a limit function. Take only whatever number specified. First is just the first line. I guess it means the same.
Do you need to collect fast always, and then you have to apply this take on
No, no, no. Oh, no, no, no. See, these are three possible ones. You can do any one of these three. I'm just trying to show you what are the possible action API. Don't think we need to always do the collect first and then the take. In fact, I wouldn't recommend collect to be done always. Because when you go into industry scenario, in fact, the collect API privilege itself will be blocked. You will not be having access to call this API, because that's an API which creates, which consumes a lot of memory, because you're trying to bring the entire data into the cache, right? So that's not something which is advisable, but any of these three API, after loading an RDD, at any point you can use.
Okay.
Apart from collect, and collect, the only reason I'm saying is in your community edition, it is at your disposal. So you can do at any time whatever API you want. But in a production environment, it is generally not recommended to run the collect API. So are we clear so far? These are just the basics that we are touching upon. So I'm not taking some complex one right now. I'm just beginning with some basic APIs. Okay. Well, let's move ahead. Now, what we will do,
Can
we
we
will
do hands-on on this, or like you will give us time?
I mean,
Because
then it becomes really difficult to know where, because we
okay,
are,
because yeah, I just typed one command and it is giving me error. So
see, that's what I'm saying. See, this
yeah,
is a single line. You can replicate me. If the moment we start writing, solving use cases, nowhere you can replicate it along with me. Even if you do, you will miss up a lot of the important concepts.
yes,
Okay.
yes,
See, it is
yes.
generally in our mindset that, okay, I will get the output, then I'm good. No, not that way, because
Okay.
now you might get the output rightly. After the class is over, if you again run, you might end up in getting an error, which you don't know
Yes.
how to solve.
Okay.
Right? So please observe this carefully and
Okay.
practice it post that. I'm there to help if in case any error comes.
Okay.
Great.
But it is like I don't think it is feasible for call you every single error.
No,
So
I'm not saying call me and ask me the doubts.
yeah.
Collect all the doubts and you can ask me. Pose a session or you can drop me a mail also.
Okay.
Okay, I'll share the mail ID towards the end of the session. Whatever errors you guys are having, you can drop me a mail also.
Okay.
Great. So let's go ahead and do like an use case. See, what we are going to do
I'm
is,
not able to connect to my cluster. I'm getting terminated even if I connect.
what's the error you are getting?
Terminated.
So how you did it? How you connect your cluster? Do one thing, keep it towards the end. Towards the end, I'll allocate some 5 to 10 minutes just for you. You can share your screen and show me what's the challenge. Okay, right. So now let's start doing some of the use cases so that parallelly we will learn how an use case can be approached and then how an API can also be used to solve that use case. So if you could see this file's content, okay, for example, I'm just commenting this. So I just want to view the top 10 records. Okay, so just see this. So this is the file I'm looking forward. Okay. Now, if you can see the content of the file is basically nothing but the content of the Stack Overflow website. So I believe all of you would have used Stack Overflow somewhere or the other, right? Now, what is a platform? It's basically about posting questions. People can answer to the questions. They can rate your questions depending upon how good it is or how really it makes sense for the platform and all those, right? So it is such kind of data. So an ID, the post ID, the score, the creation date when that question gets created, and who is a user who has posted that question. Now, we will do the use cases parallelly to understand it. So now my use case is extract the users and the scores obtained. Okay. So for example, we are having multiple fields. I want to extract only the user IDs and the score. Now the challenge in doing these kind of exercises in RDDs, they are not named data. They are not structured data. Right? There is no schema as such been available because RDD is meant to work with both structured and unstructured data. Hence, there is no hard naming structure here. Then we might get a confusion on how we can extract only this and this. Now, if you observe something carefully, whenever we are loading it with the help of text file, it converts that file into an array of string. Correct? This is basically an array of strings it tries to do. You would have seen that in Python. So what I'm going to do, I'm going to read every single line and I'm going to extract only this part and this part. Tell me in Python how we can do this. Just tell me in Python, you know Python. I'm giving you a file. I want this last bunch of data and this data. How we can do? And it is in string.
Sorry, can you please repeat?
See, I'm having an array of string here as you see. The entire file has been converted into an array of string. Now my question is, in Python, if I give you as an input and I'm asking you, can you collect only this last section, which is my user ID, and the third column, which is my score? What is the approach you will follow?
We'll split on the comma, then the last one will get ID, and the third will get the zeros.
Yes, right? Simple. It is basically, see what I'm calling about. It is a string. And I want you to split the string. Obviously, strings can be splitted with the help of split function. Split it using the delimiter comma. Simple, straightforward one. Now, when you split it, of course, they become separate columns like this. Now, each of them will carry an index position, right? This becomes 0, this becomes index position 1, 2, 3, and 4. Now, I'm looking forward to extract the index position 4 and the index position 2. Correct? See the data and tell me whether the positions are right. That's what we are going to do. So read out the line, specify the particular data that we are looking forward and extract their index position. So these are Python related functions. There is nothing new to do with respect to Spark. Whatever functions that you have learned earlier through Python, that is what we are going to adopt here. Right? Now that is going to be adopted with the help of a transformation APIs. So first, I'll again try to print it here, some sample. You will get to see how it looks like. Okay, this is what I want. Now observe one thing carefully. In this entire bunch of file, can you find there is a header information coming up? Right, which is the very first line. Do we need to process this line also?
No.
There's no need for processing that. But then the challenge in RDDs is, since it is not purely meant for handling structured data, there is no concept as such called header. Right? But we need to find a way to tweak it out. So to ignore reading that one single line. So how we can do it, just observe this. So I'm writing RDD1.header, which is basically nothing but RDD first. So when I write RDD first, I'll get this. I'm storing it inside a variable, say RDD1 header. Now what I'm going to do, I'm going to call a map API. Have you guys learned about lambda functions in Python?
Yes.
Yeah, what are they?
Anonymous block of code,
Exactly.
which can have any number of inputs, but can have only one expression.
Yes. And will it be created for reusable purpose, or it is just like a one-time call function?
It's one-time call only.
Simple, right? So all your Spark APIs are also lambda functions. Meaning in your lambda, obviously you would have learned about map, filter and stuffs, right? Now those APIs what we are going to use here also. Now observe this. I'm going to transform this RDD1 such that I'm writing the syntax of lambda. I hope the syntax of lambda you know already. So I'm just writing A colon I'll first write this down. So map is to transform the data from one form to another, right? If in case you wonder on what does this keyword map will do, it is basically just an API which helps to remove it. Now I need to skip this one single line. So before map, one more API also let's understand to filter the records. Now what it is going to do, I'm going to write a new RTD wherein I'm taking the old RTD and I'm calling the function say filter, which is also a lambda function, a not equal to RDD1 underscore header. Now what does this line do? Let's break this line down. You know about what does RDD1 carry, that entire file. From that file, filter such that A, what does this A stands for, guys? In your lambda, you would have used some variable name, X, A, B. What do they mean? What do these letters mean?
The input variable, right?
Yeah, temporary variable, right? See, I'm not talking anything new here. It is all in your Python only. See, simple. I'm writing a basic for loop in Python for I in range of 10. What does I stands for? It's basically a temporary variable. The scope of I is within this for loop. Once I come out of the for loop, I does not make any sense to me. So the same thing here also. In your lambda, I am having a temporary variable called A. Now what does A carry? A carry every single line inside this file. Like how I carry every single value within the range of 10. So starting from 0 to 9, whatever we have, I will keep on being incremented. So the same way here also, A is basically nothing but every single line inside the file. And I'm making sure that the line is not equal to the header data, which is basically the first data. So right now in your RDT2, I will get, if I go ahead and do a collect, I will get the entire data set without the first line. Correct? Can you see this now? Can you see the difference? So 7194 was a very first row, and that is what we are having here, which is basically I have removed out the header. So in your RDT2, I am having the actual entire data set to process very well. Okay. Now on top of this, you can go ahead and apply the split function. Right? Can you guys now tell me how to write the split function? Which API should I use? Should I use map or filter? For
Map,
extracting
because
only.
it will be applied on every element.
No. Somewhere it's not like map because it will be applied. Even filter will be applied on every single row. What is the difference between filter and map? Filter is again applied on every row, but it will check whether that row satisfy this condition or not.
Okay, got it.
Right? Map will also be applied on every single row. But only thing is, map will convert this row into whatever format you are looking for. Fine. Now tell me the statement. Everyone give it a try. It's just your split function in string.
Lambda A colon A dot split is. Then within brackets, the separator.
Delimiter, which is comma. Right? Now, after I split, of course, I need two index position. Right? So to extract them, again, I will write one more map on top of it. So what are the index positions I need? 4 is one I need. Correct? And 2 is one more I need. And I need to keep them in a tuple. So how do you keep a tuple in Python? Just enclose them inside a bracket. So what I'm going to do, for every row, create a tuple such that the tuple will have the user ID and the tuple will have the score. Is it clear on this line, guys? Everyone, please see whether you're understanding this line. Simple, very basic one. So if you are really comfortable in your basic Lambda functions, PySpark code is much, much simple. Great. So now, how do we view this? Probably I'll take a sample of 10. So my data set should look like something like this. An array of tuples from every single row. So if you could see the very first row, the user is 218196 and the score is 0. That is what I'm getting here. So now every row is basically converted into just the user ID and the score. Got it? So now we have collected all the users and their scores. I'm just taking a sample of 10. Don't think like only limited is there. We will be having all of them. Okay, fine. Now I'm going to give one more use case. Use case 2. Display only the users who got a score of greater than 3. Right? Now tell me here one very important thing. So the use case is simple. Extract all the people who got a score of greater than 3. Now, can I reuse this RDD2 instead of again reloading the file, doing the first function and removing the header? This RDD2, it is straight away handy with me, so I can go ahead and reuse it. Right? In fact, I can reuse RDD3 itself because here also I'm having only the users and score. And in my use case, I'm asking only the users alone. So can I reuse RDD3 for doing this use case?
Yes.
That's the best approach to do, right? Instead of, see, you can do again the reloading part, you can handle the first function, remove the header, everything. But remember, every time you're doing, at the back end, your RAM is getting hit and it will cost. So for that reason, I'm just simply going to reuse this RDD3. So what I'm going to do is RDD3 is having that entire bunch of data. Now what I'm going to do from RDD3, simple. Which API, guys? Map or filter? To extract only scores of greater than 3.
Filter.
Filter.
Filter, lambda. Yes. How we can write it after this? So you're taking every row, but on what condition? Such that the second value has to be greater than 3. Now in a tuple, how we can identify only the second value?
E of 1.
Simple. Right, A of 1 is greater than 3. Now I will get all those rows wherein the scores are greater than 3. Now I'll get the user IDs also, of course, and then along with that I'll get the score information, basically greater than 3. So I'm going to store this in a new RDD, and that RDD, let's see how it looks like. Okay.
Is there a space required between
Where?
the initialization RDD4 equal to?
No, not needed.
Okay, okay.
1 minute, yeah, there is some issue here Fill the lambda.
Talks about the greater than symbol.
It's a string actually, A of 1. So we need to write
Yes, exactly. That's where it is a not supported instance of string and int.
int of A of 1.
So where we can do that? In which RDD? While collecting them itself, while collecting the A of 4 and A of 2 itself, if I convert this A of 2 from a string to an integer, it makes sense when I'm writing this statement. So how we can convert? How is a type
Int
conversion?
that one A of 2.
Simple, right? Just only on that value I can convert. I don't mind about the user still being a string. So just we run this. So now it has been proper, right? There is a user, there is a score. Now I will rerun it. Now I could find all the users who got a score of more than 3. So there is somebody who got a 6, 11, 154, 4, so on. Clear? The reason why we got an error of not a matching operator between string and an int is A of 1 was a string and here it is a number and I'm trying to do a comparison which is not possible. Data type mismatch will happen. Okay. So clear on the second use case. So we got just the, okay, now here there is a catch. I'm saying only display the users, right? I don't need the score. So how I can do that? Right now I'm getting both of them, the users as well as the score. But the question is only the users. How we can handle it?
We can do another filter.
Why
Oh, no,
filter? It's not
filter.
Map, right? Last time we
map.
do.
Exactly. We don't need a filter. See, imagine filter is just like your where class in your select statement. If in case you are comfortable in writing queries, in your select statement will display everything. Wherein if you want to filter out only some of the records, you will use a where class. That is what filter will do. Fine. So I'm writing lambda. I don't need the index position 1. Just give me the index position 0, which is only the users. Now we got it. Just the users alone. All these bunch of people have got a score of more than 3. Clear, guys, on both the use case? Fine, we'll take a short break here. Let's take a break of around 15 minutes. Okay, we'll be back by 11:15. But when you're back, I want you guys to think about some of the disadvantage or some of the challenges that you see in following this approach. You might get a lot of ideas. Just think about whenever I'm writing a code like this, imagine it to be a bigger sized data. See, I'm showing you here just with some 5 columns to begin with, to make things simple to start with. Now scale it up and imagine it as a really huge file and just imagine writing a code on that. What do you think can become a challenge? Just let me know when we are back.
Can you show the first few lines of the code?
This one?
Yeah. Even, and where you write written collect. First collect.
This is a one.
Okay. Okay. Before collecting, you just even.
These are just like descriptive statements for you.
Okay.
Like a comment section.
Yeah, I got it. But I'm getting error at input path does not exist for
Then it
this.
means the file that you have copied is not present. You haven't uploaded it.
I have uploaded, and when I've written the collect statement, it got executed. But when I execute the text statement, it is not getting executed.
When you're getting
Take.
text.
Yeah, function.
take, and within that you have to specify a number. You're doing that?
Yeah, I have done that. RDD1.take10
Okay.
into
I will see
bracket.
it once we are back. Just share your screen or just copy all the comments that you have typed down and send it on the chat. I'll check. There might be some syntax errors. That could be the only reason. Okay. Fine, guys. Let's be back by 11:15. And take it forward. It's 11 right now. So let's be back by 11:15. Yeah, shall we start? Shruti, the error is the file is not available, which means the path is not proper, right? And collect should have a bracket, starting and an ending bracket in it. That's a collect should have a starting and an ending bracket. This is why I'm saying just don't exactly do it along with me. You will only miss a lot of stuffs.
Can you show that?
No, after
Sorry.
collect, open and close bracket. That's it.
Okay, open and close. Okay. And after running collect only, I have to run the. No, I
See,
can.
the file itself is not present. It shows you haven't uploaded the file inside. Go
I
to.
have uploaded the file.
Then it should
Is the
not be
name
having
of the
the.
file RDD1, not RDD2?
Go to DBFS file store.
Yeah, it is there.
Drop down copy.
Copy path.
See, what is a path? Yeah, copy it. I'll tell you. What is a path?
DBFS file store.
No. See the entire path.
Okay.
There is tables. You haven't written tables. Not the file API format. Spark API format on the top.
Okay.
Close. Now paste it on the path. File you have pasted in some location and you called it in some other location. That's the challenge.
Okay.
Yeah, you can stop sharing.
Yeah. Okay,
Fine.
got it. Thank you.
Let's go ahead and continue. So, have you guys thought about what could be the challenge in doing like this through Spark?
Loading time.
Loading time wouldn't be a challenge. Loading time, any operations that you're going to do will be loading will be involved. Loading is not a challenge at all.
Okay. Or like a count of rows, or like here how we are able to select 1, 3, 4, like number of rows we want to select.
No, the challenge would be specifying their index positions.
Yeah, that's what.
In a file which is of just having 4 column, it could be okay to identify and track the specific column with the help of the index position. But if in case I'm going to have 100 or 200 odd columns, locating the column where I want to perform some operation itself will become challenging. And going by that, specifying the 4th index, 5th index, because it's not a named process. The whole core Spark is basically not a named process, meaning there is no structure behind it. So that becomes certainly a critical part when we work with Spark Core. And that is one of the reason RDDs are slowly getting diminished. The usage of RDDs is not much nowadays in the industry. Rather, data frame is what people do prefer because that's much more easy and named one. Fine, we'll do one more use case. So I'm going to write, find the total score obtained by every user. Now, if you could see the data over there, right? See the sample. Now, there is a possibility that the same user has come again and posted a question and which has got a score. So not necessarily a user should come only once. A user can come n number of times depending upon how many questions he or she is having. So for example, let's take this person. So 218196. Let's imagine he posted a score and got a score of 0. Again, he posted got a score of 1. He got a score of 10. Now, another person, 903061, they got a score of 2 and they got a score of 10 and so on. Now, what I want is the final output should be 218196 has got a total score of 11. 903061 has got a total score of 12. So this is what I want in my final output. Right. Now how we are going to do? Let's see. So to do this, there is a new API that we are going to learn, which is called reduce by key. Okay. Now again, let's go ahead and see which RDD I can reuse. I cannot take RDD3 because in RDD3 I'm having only the users and this score. I think I can take this because anyway, to do this use case, I need only the users and score, right? So I can definitely reuse RDD3 itself. I have user ID, score. Perfect. Let's simply reuse RDD3. Okay. I'll show the RDD3's output one time. Okay, this is how it looks like. Great. Now, what does this reduce by? Pranjal, we are yet to see the data frame. We are just starting up with RDD. Sorry. We'll move into the data frame. Okay. This is because only in core Spark wherein we are dealing with RDDs. Fine. Now let's see how this reduce by key API works. It's a transformation based API, which means it can help transform the data to another file. Now there are few APIs which has their name which ends with the word by key. So reduce by key is one. There is something called group by key. There is something called sort by key, aggregate by key, and so on. Now, what does these API do? Whenever the word ends with the letter by key, it means it is going to work on a pair RDD, which means there is a tuple which carries key and value. And whenever there is a same key repetitively coming up, then their values are reduced into one single value. So for example, in this case, how it comes? 218196 is 0 first. 218196 is 10. 218196 is 2. Right? Now, whenever the keys are same, that's why the concept is as such as reduce by key. Okay. So whenever the keys are same, their respective values are summed up and the values will be given to you. So the output would be 218196, 12. And this reduction will happen recursively, meaning how many number of times you will get that same key, all of their respective values will be summed up and given to you. Now, the same way for every other user also, you will get their respective output. That's what a reduce by key is going to. So let's see the syntax on how we can do this.
Can you repeat one more time?
Yeah. So write reduce by key lambda x comma y x plus y. What do you mean by this x comma y? X and y are basically nothing but the values of the same key. So whenever a 2181 comes, it can have n number of values. So the first value will be considered as x, second will be considered as y, and I'm summing it up together and I'm getting the final value. Now the same way for every individual user, it sums up their respective value. And now if I store this, and if I could view their output, it will basically give me the summed up value for every single user. Now there are few users, even if you sum them up, they are having only zeros because the overall scores that they have got is just 0. So there are few users who has got 26, 2, 3, 10, 6, and so on. Right? So what does a reduce by key basically do? You have a key value pair. You are summing up the values based on the same key. Then write this logic. So this is repetitive addition. Now, suppose similarly you want to perform a repetitive subtraction or a multiplication. All the 5 basic arithmetic operations can be done here. So you can do a repetitive addition, a repetitive subtraction, a multiplication, a division, and a modulo also.
Can you explain like how it is like connected with x and y? I'm not able to refer x and y as a.
The first value of your key will be x. The second value of your key will be y. So that's what I have written here. No? 2181. Initially, I'm getting 0. Then the same 2181, I'm getting 10. So this is your x, this is your y. They will be summed up together. Similarly, the next value will come for the same user. Now this will be 10. This will
So
be
we are getting
both of them
totals of saying every user, totals of every user, or aggregate function.
Yes.
Okay.
Okay. So this is a total score with respect to every single user with the help of your reduce by key. Now the same logic can be achieved with the help of one more API also, which is called group by key, which is quite similar to the reduce by
SQL.
key.
Sorry.
Please stay on mute. Only when you have questions, you can unmute and talk. There are a lot of background noises which can disturb. Fine. Now, what is a group by key? It is quite similar to your reduce by key, but then the difference here is group by key can do all the basic 5 aggregate functions that we have seen in our SQL or in Pandas. So, what are the aggregate functions that you can do with the help of your group by statement in SQL? In SQL, you would have used group by, no? Group by keyword. Min, max, sum, count. One more you missed, Insha. What is that? Average, no? Right. Now the same thing can be achieved over here also with the help of the group by key API, which is min, max, sum. There is no count as such, but there is a function called length, which is again doing the same job as your count. And the thing is, there is no average out here. Directly, there is no average keyword as such, but we can tweak it with the help of dividing the sum by the length. So which is basically like sum by count. Okay. So I'll again do this with the same RDD. So I'm taking RDD 3 dot group by key. Now remember, group by key again has to be applied only on a pair RDD, which is a tuple of key value pair. Right. Now, after doing a group by key, see the syntax, I have to write a map because what is the group by has to do? Because in group by, unlike in your reduce by key, wherein directly you can specify here, in your group by key, it will take the values grouped up based on a single key, and what you want to do on the value, you have to explicitly specify here. So I'm going to write, give me A of 0, which is your key, which is your user ID, and give me the sum of A of 1. Correct? What is this one will do? Every single user and their summed up values. Correct? Now, instead of storing them on an RDD and then writing a collect, directly also you can write a collect function here itself. That is also possible. See, so far what we are doing, capturing it in an RDD and then calling that RDD.collect. But directly also you can do a collect. So it will not be storing them inside a specific name. Rather, it will be temporarily doing the job and displaying you the result. Now see the output. This is again the summed up value with respect to every user. Just compare this value with the previous value. So 218, 196, 15, so on and so forth. The same comes up here also. So group by key will do the similar job of that, but within the scope of these 4. Okay. Now suppose I'm trying to do, okay, let me show this one, which is min of. So what do you think will happen if I do this? Think and tell me.
It will come 0 for every user.
Why 0? What if that user has got a minimum score of 10?
Ah,
Right?
yeah.
Whatever is the minimum score that the user has got.
Yes,
So
yeah.
it's not necessarily been 0. It could be anything, whatever is minimum under their bracket.
Yes.
So
1.
there is 0, there is 1 also there. There might be some other. So there are few users. See, there is 154 itself is a minimum for
154, yeah.
somebody. So it depends upon the data. Now similarly, if I change this into max, I will get whatever is a max value with respect to every single user. So again, some of the users have got only a score of 0. So their min is also 0, their max is also 0. And similarly, you can have a length. So when I go ahead and do a length, it will tell you. Okay, now a simple question. So why the length is nowhere 0? See, randomly, if you pick everything, nowhere it is 0 for the length. Why so?
It is holding at least one single review.
Because only when the user is given or posted a question, that's where the user is basically been added inside the file. There has to be a minimum of 1 entry, and hence the length is at least 1, it will never be a 0. Clear, guys, on group by key and reduce by key?
Yes.
Still, I have
So
one doubt here.
Yeah.
Sorry, yeah.
Go ahead, George, go.
Yeah. You mentioned that min and max, and it's acting upon only the last column, right? I mean, the value column. So basically, it has to be a range of values, right? Then only that's logical to have min and max, right? So if we are comparing it only with the last, only one value is being supplied. So what is the logic behind that?
Then that will be the min, that will be the max itself.
Okay.
Say, suppose there is somebody with the user number 10, he has posted only one question and he has got a score of 0. There are multiple people, they have repeatedly posted multiple questions. Then for this guy, I know there is no range, but this itself becomes the min value, the max value, the sum value also. And length will become 1 for him.
Okay, got it. So this functions will always be act upon just two values, right? Key value, not more than.
Correct. Yeah, that is the catch here. So, I would say that's a limitation, because the solid here is it can only be a tuple, a pair of values can only be inside it. Now, there are some situations. See, suppose imagine I'm asking you to give me the user ID and the question ID also. And then give me the score also. Then, of course, it can be still achieved. What you can do, the key, just do a concatenation between your user ID and the question ID. So now together this becomes key and the score becomes a value. So that way you can achieve. So it's not like you cannot have more than one value in your key. You can very well have, but make it a concatenation so that at a single value you can view it.
Okay, yeah, got it. Thanks.
Got it? Great. Fine. Now let's see one more API also, which would be your sort by key. What is the usage of a sort by key? Simple again, I have a key value pair. If I want to arrange them based on the order of the keys, I can go ahead and use a sort by key. As simple as it is, it's not a complex job at all. So again, I'm taking the RDD3, I'm writing RDD3 dot sort by key of. Now, do I need to pass anything inside? Inside your sort by key, what do you think? See, as a name itself clearly say sort it based on the key. Now, like in any other programming language, by default, the sorting order is going to be ascending always. If at all I want it to be in the descending, I can pass a parameter, say false inside it. Like how in your SQL or how in your pandas data frame, we have the DESC keyword to arrange them in the descending. Here it can be a false parameter that will make sure the keys will be displayed in the descending order. Now have a look on the data, you can understand. Yeah, now there is some confusion here. Let's see who can find this. It's not properly, no, it's not properly arranged. What is the reason? I'm asking sort by key in the descending order, but what I could observe is they are not arranged in the proper descending order. Why so?
It's
Simple.
sorting by the key, the
No, it
ID,
sorts by the
the
key,
user.
but then that's not proper, no? See, this is a higher number, this is a lesser number, this is much more lesser than that. Simple, because it is a string. We have only type converted the value, we haven't type converted the user ID. Correct? So that's the reason. So I'm going all the way up to RDD3 generation. Yeah, here I will change this also to an integer. I'll rerun this. Now both of them have become integer. Now I come to the last step. I'll rerun again. And I could find the data being proper. Got it? This is in a descending order. Now the same way, if at all I want to do it in the ascending order, just don't supply anything inside. That's it. Got it? So this is how your sort by key works. Now one more extension of this, which is called sort by, also is possible. Meaning, suppose I have a tuple of key value pair. I want to arrange them based on the key. Then I can use a sort by key. But suppose if I want to arrange them based on the value, I cannot use this. Right? Suppose I want to display the output based on the scores that they have got. Then this cannot help me. So that's where you can use one more, which is called sort by. So the same RDD3 I'm going to take, but I'm going to write a sort by. Sort by on which column? See, in this case, I wanted to sort it based on the value. So I'm writing index position. You don't need a tuple here because it's a single. And I can either arrange them in the ascending or in the descending. If it is arranging, if it is in the ascending, this itself is enough. Right? See this? So all is 0. Because there are so many people who have got a score of 0. So all zeros are coming up first. Now suppose I'm passing a false here, then it becomes descending. That's it. So let's see the topmost score. There is somebody who has got 313 score, which seems to be the highest. Got it? So unlike in your sort by key, sort by can be applied on any tuple, not necessarily a pair, right? Now suppose I'm having a tuple which has a value 1, a value 2, a value 3, so on all the way up to value 10. There are 10 different values. You can sort that entire tuple based on the 3rd value, 10th value, 5th value. Very well we can do with the help of sort by. Clear, everyone? Any questions so far? Great. So now, so far, whatever we have seen, now they are RDD based operations, though we are not covering everything because, as I said, RDDs are kind of slowly being not used in the industry. In fact, most of them are being moved towards data frame because that proves its edge. But then I don't want to skip the entire RDD portion. That's where we have seen because this can help you as a base for learning data frames also. Now, some of the biggest challenges on working with Spark Core or RDDs are processing a huge file, especially when they are much more structured, it becomes really difficult because locating their index positions becomes very hard and handling out the header informations becomes really hard, right? And whenever we need to process such file, not just on the very first time identifying their index position, going forward also locating the specific index position becomes really challenging. And that's where the Spark core operations or the RDD based operations can be much more enhanced with the help of the next component, which is Spark SQL. Right? But before I take you into this Spark SQL based operation, one of the very important concept we will understand, which is called lazy evaluation approach. Now, somebody asked this very interesting question on what happens when we reach or when we hit the threshold of my RAM space, right? Because I'm keep on dumping stuffs inside RAM. It might reach the threshold quickly, right? Now I'm going to handle it. One of the one of the ways Spark is adopting to handle it out is called lazy evaluation. So just observe this. So I'm going to catalog. I'm picking up any one random file. Okay. For example, let's take this YouTube MySQL. Now, remember, there is no file called YouTube MySQL 0. Okay. See, it arranges everything as per the strings. So there is nothing called MySQL 0, but I'm going to call it. MySQL 0 is what I'm going to write. So sc dot. Now tell me, what do you expect when I run this line? What do you expect when I run this line? This file is not present. What do you expect?
Error.
Okay. Okay. Let's see whether it is throwing me any error. Is it throwing any error? No.
No.
It is saying it gets executed. Fine. Now observe one more thing carefully. I'm writing RDD 0 dot. Now remember first, there is no such file itself, but I'm trying to split it and trying to fetch some index values, right? Now, even when I run this also, it is not throwing me any error as such. It says the statement is completed. So what is actually happening? Because what we have seen is the file, first of all, is not there. So when the statement get executed, when this line get executed, ideally I'm expecting an error. And even this line, wherein I'm reading from the previous line, splitting it, locating only the first index value, here also I'm not finding any error. Now, the reason for all of this is, let's see this. I'll store this in one more RDD, say RDD1, and run it one more time. Again, no error. Now RDD1 dot collect I'm going to. Let's see what happens. Can you find an error? Right. Now only it reports that error, which I was expecting when I ran this line. So what is actually happening here? This is what the lazy evaluation approach do, which means, see, this is a transformation based API. This is also a transformation API. This is an action. So basically what happens in any Spark related operation, it starts from the very first RDD. Okay, there is the first RDD. Then after that, RDD1 is there. After that, RDD1 dot collect I'm writing. Now, the moment you are hitting an enter after writing this line, what we basically expect is the statement to be executed. But ideally, in your Spark, this will only be compiled. Right? They will not get executed as such. Any transformation API that you're calling will not be executed right after you hit enter. Rather, it will only be compiled. The moment you hit an action command, then it backtracks. Okay, now you are asking for RDD1 to be collected. So what I have to do, I have to go to the previous line, execute this line. But in order to execute this line, I need to know what is RDD0. So I have to again backtrack and go here and run this line. Now when I run this line, I got to know there is no such file. That's why the error came out. So basically what is happening here is it just backtracks and go all the way up to the statement where your action API is basically getting called. Now, in order to do this, see, I'm writing just only 2 steps so that you guys can understand at the very beginning phase. Now, suppose imagine you're working on a huge project where you are having RDD starting from 1 all the way up to RDD 100. And also remember one point, like I'm explaining here with RDD 1, 2, and so on, but it is recommended to give a solid string name for your RDD, like RDD load or extracting user ID or extracting the high score. So something meaningful of that sort is always needed, instead of randomly throwing names like RDD1, 2, and so on. Now the challenge is, when I'm writing these many lines, imagine starting from RDD1 till RDD99, all of them are some transformation statements. RDD100 is only an action command. Now, it needs to have this entire path somewhere stored, right? So that it can backtrack and reach all the way up to the very first statement. Now, how it helps to backtrack? Now, that is where and another important term you should be aware of, which is called DAG, which is called Directed Acyclic Graph. Meaning, I will have that complete history of operations one after the other, what needs to be done with me, so that whenever an action command comes, I will refer this DAG, I will understand, okay, these are the steps I need to run back, go to the topmost one, start the execution. So now only the execution begins. And remember, when I say now only the execution begins, now only the data will be shifted towards the RAM. So I'm not making any data unnecessarily sit in the RAM whenever it is not needed. When you hit a collect only, it is needed. So it backtracks, goes and stores the data inside the RAM and starts it processing. Now that's how I make the RAM space efficient in terms of processing. I'm not keeping any unnecessary data inside the RAM. During the time of execution only, whenever the data is needed, I'm pushing it into the RAM, finishing that entire process, clearing it out automatically from the RAM. Does that make sense? You got to understand what is DAG, backtracking. Now this
I
whole...
understand backtracking, but DAG is not clear yet.
See, DAG is nothing but this picture in hand, this structure. See, that's what I said. If suppose you have 100 or 200 RDDs, you need a ready backup in hand on knowing what is the order in which the RDDs needs to be executed. Right? So the moment you hit the second line, there is a connection created between RDD0 and RDD1. Tell me, after running this line, what are the two RDDs which are connected?
RDD1 and RDD0.
That's what happens. That's what happens when you build a DAG. Suppose you go all the way up to 100, you will be having that upright with you. See, what if in between any one of the node where, see, these things you have to now frame up logically in your head. What if the system on which your RDD1 goes down? Then I need to rerun it somewhere else where I have a replicated copy. In that time, only a DAG can help you how I can connect that with the earlier upcoming RDDs. Right? So DAG is a very critical part whenever we are building any of the Spark operations. And this entire step of executing the RDDs only after an action command is hit is called lazy approach. Now, why such name? Because immediately it's not executed. Only when you call it, only when an action is called on it, that is when the previous statements are executed. Since it is immediately not executed, this process is called lazy. Okay.
So does it mean that the DAG concept is for backup plan, as a backup plan, kind of?
Not only in backup scenarios, it is always created, but it is proving its efficiency whenever a failure happens. It's not like during the time of failure only your DAG gets created. DAG is always created. It is a reference for you, for your executor to understand what are the series of steps you are executing. Okay, so this is getting compiled. I'll show you one more way to understand that it is compiled and not executed. See, text file is an API name. Text file 0, there is no such name, right? See, when I'm running this, now I'm getting an error saying there is no such attribute called text file 0. Because this is a compilation error, wherein the file not found is a runtime error. Right? Basic programming concept. So whenever an RDD is getting created, it is only compiled and it is not getting executed. Is it clear, guys?
So one thing, once we run the RDD1.collect, it gets stored in the memory, right? And when we are running it again, will it backtraces the DAG again and execute it, or it will simply fetch it somewhere in the buffer? I mean, the DAG execution will repeat again?
You mean the second time when I'm calling that same statement?
Collect, yeah. Yeah.
No, not needed to execute again because the collected data will be available in the RAM itself till you move it into a hard disk location. So there is one more API which is called save as text file.
Okay.
Okay. During that time only, it will be stored inside the hard disk from your RAM. So whenever you are just calling either a collect or a take or a first, it is only available in the cache for you. So even when you rerun is, no need to do a recalculation. Just pick it up from your cache and display it out.
Okay.
And this brings me one more point. See, suppose imagine I'm not doing a collect, rather I'm writing rdd1.save as text file. Now, what do you think will happen to the rdd0?
RDD0's reference still be there in the memory, right?
Not needed, no, because once you calculate and store it inside your hard disk, RDD0 is basically become an intermediate output that is not needed anymore because you have reached the final output. I don't want anything to unnecessarily occupy memory in the RAM. So once you save the output into the hard disk, as per the DAG, what are all the previous RDDs we have, all of them will be automatically erased out from the RAM so that I can use it for my upcoming files.
Okay, understood.
Right?
One other follow-up question here. Let's say after we saved this, if any other statement, if we call it RDD0 again, in that case, it will do the DAG.
That will rerun.
Okay.
See, yeah, I got your point. So you are saying RDD0 I am doing, RDD1 I am executing. Now I am calling RDD1 dot save as text file, right?
Correct.
So the entire operation is completed, purged out. The final output is there inside the hard disk. Let's say C drive or D drive or what.
Yes.
Now when another user comes in, now he is trying to call RDD0 dot connect, right? Basically what happens is now you have to redo that, because now the earlier RDD0 which was erased out is no more available inside the RAM. So basically you have to recall again the RDD0 calculation, RDD1, and then only you will do this.
Okay. So the DAG reference will stay there. Right?
Yes.
Okay.
Yes. See, the simple thing here is, I mean, for argument's sake, we can say, okay, I'll call this one more time. But then as per your real case project scenario, I will not do a save as text file unless I finish the entire operations inside my DH.
Okay.
Right? Now, suppose there is a module which carries 5 different operations. You will not store the output immediately after the first operation. You will finish all the 5 sequence of operation. The 5th operation is what you will be storing it. Now there is no need for you to again recall the second operation because you have finished all your previous operations.
Yeah, that's true. I mean, once my data set transformed into as per my requirement, then like only then I'll be saving it, and that will be served as a template for subsequent repetitive operation, right?
Another
So
operations, yes.
that is
So
true.
it's basically like a pipeline which gets only completed after I finish the entire process.
Yeah. Okay, got it. I mean, this question I asked for the understanding purpose, the RDD0 recalling.
Yeah. No, that's true. I mean, more of such thoughts is always welcoming because that's when we'll get a much more clear picture on the understanding. I'll also show you guys that save as text file because that will also be good. We are not going to use it in our things. I'll just show this and then probably we'll wind up. And so unfounded, okay, this is fine. Anyway, I'll show this also. Unfounded data, something like this I'm doing because now itself the error will come. So you will not be able to proceed further because right after the collect comes itself, it will throw out an error. Now what I'm going to do, I'm not going to call the collect, rather I'm going to call the save as text file, which is again an action API. I cannot do it because I don't even find the file that you are talking about. Got it? So similar to collect, save as text file is also another action API. The difference is this will be available in the cache, wherein this will make the data to move into your disk. But irrespective of that, in both cases, your job will not run because there is no such file available. Okay, guys, I'll share these sheets with you. Even if you want to share the sheets with some of your friends or something, what you have to do is go to File, okay, go to Export Notebook. It gets downloaded on your system. This one also, Export and Notebook. That also gets downloaded. So both of your files, they are available as a Python notebook. I will attach this on your respective drive.
Can you paste it here in chat?
Yeah, let me first store it there. Anybody is having your drive link handy with you? Can you put it on the chat? If you have. To search
How
out.
many more lectures we need to do we have with you?
No, I'm asking.
No. It's a different question I'm asking entirely.
Tell me.
I'm asking how many more lectures do we have with you?
One second. I'll just pick this up and then probably I can come to the questions. Give me a second. I'll upload the files that I'm using in the class also so that you guys can use it, which is that social media comments and the YouTube file. YouTube probably we will be using in the tomorrow session, but I'm uploading them also here. Okay. Yeah, now you can ask me. Yeah, tell me, is there a question? DAG is stored
Sorry,
in
I
which
was
form?
muted. I was only asking how many more lectures do we have with you?
I'm sorry, I cannot understand. Can you please repeat slowly?
Like, how many more section do we have with you on this on big data?
Okay. So overall, it is a 14-hour session. So tomorrow we do have, and then the next weekend, Saturday, we will need 2 hours.
Okay. Thank you.
And to answer Ram Srinivas' question, which is on DAG is stored in which format? DAG is stored in a graphical format, which will be like, probably you can relate it to a flow chart, a simple flow chart that you can create in Microsoft Visio, or just like a flow chart that you can find in any pipeline. In MongoDB, if you guys have used the aggregation pipeline, it's quite similar to any pipeline, just like a flow chart.
One other simple, question I want to understand the Spark core and the SQL. So the Spark core also can handle the unstructured data, right? Not
Correct.
only the. Okay.
Yeah.
So whatever we learned so far is just processing the structured data, just
Correct.
CSV.
Yes.
Okay.
So
But when
whatever
it comes,
we have seen so far is only about handling the structured data. We can handle an unstructured data also in a similar manner, but then again the challenge over there is splitting them across and extracting the needed data from a specific index again becomes a challenge, even if it is an unstructured data.
okay.
Okay. That's not a part for you, but what I'll do, I will be sharing in another notebook which has Spark core on handling unstructured data. Okay, please have a
Sure.
look on that as well. As it is not a part of the module, I'm not explaining in the class, but if you guys can just have a look on it and understand, because it involves all the API that I'm using in the session.
Sure, Sylvia. And again, Spark data frame also deals with it, right?
Spark data frame can highly deal with structured data,
Okay.
but the thing is it can handle different file format which core cannot handle at all.
Okay. Got it.
Especially Parkway files and RDBMS based data. So Parkway files are very, very important when it comes to big data, because most of the big data platforms out there use Parkway file format, and Spark data frame can efficiently handle it and process it. So that's one very important advantage of it.
Understood. Yeah. Thank you.
Spark PPT also. Okay, I will upload. No worries. Fine, guys. Anything else we need?
I just missed that question raised by George. So we'll be covering the Parquet data concept, right?
Yeah. We'll be covering tomorrow. We will handle different file formats which we can use in Spark data frame. Tomorrow we'll start the Spark data frame concept. So first half, I will show you how the different file formats can be converted. And then the second half, we will see what are the processing that we can do.
Okay. Thank you.
Yeah. And a link I have shared on the chat box. Whenever you find time, please go ahead and have a good read on the link. That's the official website for Apache Spark. That gives you a much more deeper understanding. See, before we wind up, one point I would like to share. See, this whole big data as such a technology itself is really huge. And covering them up in a 14-hour course obviously has its own limitations in sharing what are the contents that we need. So if you ask me separately for a big data developer course, it comes around to 30 to 35 hours, wherein in and out we will discuss about everything inside the coding and stuff. But then since this is just one module in your entire course, this deserves just 14 hours or 13 hours of study, and within which we are trying to deliver you whatever maximum needed for a profession, for a data professional. But if you are finding this particular module to be much more interesting, please go ahead and have a read on these websites, which are their official website, which gives you much more deeper understanding. Great, guys. So if we don't have any questions, we'll wind up and we'll connect back again tomorrow.
Thank you, Soumya.
Yeah.